This is another update for Gallian. In this update, I finished section 10, and then I started on problems in section 11. And I also read section 11, and I think I have mentioned that before. Yeah, I had mentioned that before, that I had read it a little bit ahead. I did not calculate how many problems I've solved. 715 over 1688. But in this case, yeah, so that's where I'm at. And I think that is not halfway through Gallian. The halfway would be 844. So yeah, I'm like 45% in. I'll calculate it later and check. But yeah. All right, so that's what I have for the path of where I'm at. So I completed all the problems in section 10. Group homomorphisms. And yeah, I believe that I mentioned last time that I had to read some and go into the interwebs, but I'm going to mention some more from last time that I did do even more of going and checking videos, just because I feel I'm really beginning. I did find in section 10 that Gallian could have explained some things better for me as a self-learner. Maybe he wasn't intending to have me as an audience, and so that's fine. Yeah, and I've already shown all this material, and I believe I may have even shown, I don't think I've shown section 11, because I'm going to show that I read it. Yeah, so in this case, this section is a lot more straightforward than section 10. I did not have to go too far out there and read. Yeah, this seemed to be a much more straightforward section to read. So you take a finite abelian group, and then you turn it into, it's isomorphic to a product of a bunch of integer groups. And there's a whole procedure by which you can break up all the possibilities. And then for whatever group you have, there's only going to be one of these that is actually going to be isomorphic. And you play the game of what are the different orders of the elements. So as explained here. So you draw what are the orders are. You look through your groups and you're like, well, C16 definitely has an element of order 16, so it's out. Z8 has an element of order 8. There are no elements of order 8, so it's out. So it's really down to the last two groups. And then you do your logic and you nail it to Z4, Z4. Now, in some cases, and I'll show it, I actually calculated them out just because it was the groups were not so large as for me not to be able to do that. That was two negatives. The groups were okay for me to be able to do that. Then the fundamental theorem, which of course is 11.1, gets a long proof, which I really liked. I thought it was very readable, broken up into various lemmas. Yeah. And it's got a nice selection of problems. And I'll talk about those now. Okay, so from the last time, I think I stopped at problem 46. And I showed problem 47 as well. When I read the answers for some of these, I'm like, yeah, I got it. That's exactly what they're saying. I didn't even need to write out what the answer was, because sometimes in my answer, when I look at the book, it'll have what I think is a better answer. And sometimes I'll think that I solved it right and I didn't. And then the book has an answer. Yeah. N is a proper subgroup of G. Every subgroup of the factor group G of N has the form H of N, where H is a subgroup of G. Take theorem 10.2, part 7. I drew a diagram for it. Yeah. That was my exploration. This is the actual proof. You just map the kernel, figure out what the kernel is, and lay out by theorem 10.2 that indeed this is correct. This statement right here is correct. Yeah. And the inverse function of H of N is the one that comes back to here. I don't have an answer for that. I just put whatever I could. 53, I got it right also. then this is where I hit a little rough spot. Yeah, I hit a little rough spot. I was trying to figure out, define all homomorphisms either from D5 to Z2 or from C2, from D5 to C2 cross C2 or from Z2 cross C2 to D5. This was not really explained in Gallian, I believe, in a way that I could understand it. I'll link them in the video. And I made a post about Matthew Solomon's wonderful YouTube series on abstract algebra. It's really amazing what he has. He's taught the courses multiple times, and he's made videos for every single one of them. So he's got hundreds of videos. It was great. Very good exposition. And so from him, I learned that when you have two groups, if it's isomorphic, of course, everything is 1 to 1 because it's got to be 1 to 1 and onto. It's just a function. It's an invertible function. In linear algebra, it would be an invertible transformation. But once you have a homomorphism, you loosen those rules, and you could have it where everything in the from group is mapped to the identity of the to group. All right. And you could have that. And of course, you cannot map anything in here to a higher order, but you can map everything in here from a higher order to a lower order. That was not explained to my knowledge in Gallian. And so there were some examples that I drew from his videos, and then I could finally get going, and then I could finally go and do the various homomorphisms that were being asked. This is an even problem, so I don't know if it's correct. But yeah, in the case of 55, I got it correct. Yeah, 55 was very straightforward. I understood what he was asking. And 57 and 56. 56 is also correct. Yeah. Yeah. So then I could understand what I was doing. But that, I believe, is something that I believe Gallian should have done a better job at. More of understanding how all these groups are mapped in the from and the to in the homomorphism. Yeah. Once I drew these diagrams, I was home. I could understand what was being said. And then, of course, 61 was very interesting because this is kind of interesting because the Gallian goes from problems that are very, very hard to me, or hard or poorly laid out, to problems that seem completely trivial. So there's an example 17, okay? And example 17 is the groups are 5 and 7, total 35, okay? This problem is exactly the answer to problem 61, except instead of 5 and 7, it's 7 and 11. So this is really just a rewriting of what I just showed. And of course, it's correct because it's a retelling of the same story. More homomorphisms where when I looked at the answer, I was pretty close after Solomon's beautiful lectures and explanations. Yeah. Yeah. Things got a lot easier after that. I really understood what I was doing with the homomorphisms. Then I read section 11. Of course, nothing to work out except maybe here. Looks like I worked them all out. Yeah. Well, these are worked out. No, I did Excel. That's right. I did this in Excel to work out the example in full detail. I like to do that. The proof of the fundamental theorem. I'm just reading here. There's nothing to see here. And then for section 10 problems, yeah, I screwed up. I forgot that it's not 6 squared because 6 is not a prime. That was my mistake. I forgot Z4 by C4. Yeah, but then once I started playing the orders game, these were straightforward problems. Yeah, and I forgot something sometime. Every now and then I'll miss a little something, but I understood what I was doing. Yeah, just playing that orders game. And then in the case of 15, this is actually gonna get this video, the previous weeks and the following weeks are gonna be similar in that in all videos I say, or the first two, the next one's going to say a lot more. I did this whole thing. I thought it was beautiful. It's all completely wrong. It's not about subgroups. This is all about, Gallian does not really explain in section 11, okay, something that is explained later, that it's very different to find the group homomorphisms than to find how many abelian groups are there for that order. And if the order is P prime, there's only one. But if the order is PQ, there's also only one. And that was not explained here. It's actually done in the next section that I'm going to cover, which is section 24. And of course, in section 24, there is a table. Okay, and I'm going to zoom in so I can show it. And of course, next week's video will also have this description. And sure enough, when you go in here, 10 is 2 times 5. There's only 2 groups. Let's find another one. 31 times 2 is 62. There's 2 groups. And of course, it's all right here. And once again, I should have zoomed out quicker. But that is something that I didn't like that. Threw me for a spin. But then that meant that I went in and I looked at Dummett and Foote. And Dummett and Foote really set me straight. Okay, so also one final programming note for where I'm going next is that because I want to cover all of the group theory material all in one shot, I'm actually going to divert and not go into rings, even though I'm right here in the next video. Because what I want to do is finish all the group theory that is in the first section. I think I know what Gallian did. So what Gallian did was, hey, I don't want to lose the thread of your course, your 1 semester course. If you decide to cover all these 11 sections, you're not going to have a lot of time to go all the way through and finish all the way to maybe all the way to here. And then maybe you want to do some Galois. You want to pick from the latter content. But if you put this group theory stuff up there, then you've got a big chunk of material and then a lot of material that you may not cover. I see what he did. So what I'm going to do is after 11, I'm going to jump to 24 and do 24, all the group theory sections in the back, all the way to 30. And then after I finish these, then I'm going to come back and pick it up at 12.